Now I got the recording going. Okay. Now let me get back to the chat window so I can see that. Okay. All right. This week there is a lot of material in Chapter 11. So I have split it into 2 sessions. It's not going to be first half versus second half. I can already tell you that, but the very first thing, I'm really going to cover more in the second half. My intention is we'll cover general stuff about IP version 4 addressing here in the today, and then Wednesday, I'm not sure what I'm seeing. Okay, for some reason, it's wanting to show me some different stuff there. Now it's seeing normal. Okay. All right, and then Wednesday, I am going to do 2 more sessions, a morning one and an afternoon one, at the 10 o'clock and 2 o'clock, just like I do the 10 o'clock today and here, and tomorrow I do the 2 o'clock. And in that one, I'm going to do subnetting, and I've got to have my drawing pad with me, which I left sitting at school when I just left a few minutes ago to run home and do this. And my laptop continues spinning. So in Chapter 11, so you're going to have 2 sessions. However, for getting credit for the discussion, I'm not going to require you to attend both. I'm just going to require that you attend one of the 2. So you can attend today, you can attend Wednesday, you can attend both. If you attend either one, I will give you credit for the discussion this week, and participate. And then, so that'll be what we'll do on that. So realize on that on it, okay? Thursday, I am speaking at a conference in North Carolina, so I'm going to be tied up part of that day speaking at 3 sessions for them, ironically on number systems, which relates specifically to what we're doing in the chapter here with subnetting. And then the second thing I'm speaking on to them is subnetting. So it hit exactly right on with where we are in the class. So I'm doing 3 of those during the day on Thursday. Also, the foundation has a luncheon for those of us that contribute to the foundation on Thursday. So I'll be in Calhoun for that. So I'll do my morning session that I'm doing for North Carolina from down there in Calhoun that morning. Go to the luncheon because I speak from 11 to 11:45, I believe it is. Luncheon starts at 11:30, and then I speak again, I think at 3 o'clock and 4 o'clock afternoon. So full day. Friday, I probably I'll be offline, and I know in the afternoon, some in the evening. I'm going to the Key Club convention for Kentucky, Tennessee this weekend. Starts on Friday evening in Franklin, Tennessee. So I'll be up there this weekend, but I'll be online through the weekend. And then things hopefully settle on down. I'm pretty well over whatever I had last week. I'm still not 100%, but when you don't eat for several days, that happens. All right, so we're looking at IP version 4 addressing in Chapter 11. This used to cover several chapters, so that's where part of this gets into. So we're going to be looking at how IP version 4 addresses are set up and how they work, and then we're going to get into subnetting, which is where we can take a group of IP version 4 addresses and break them into smaller groups. So they're going to go through and teach you some basic things about IP version 4 addressing and about why would we segment our networks, which is where we would use the subnetting to come up with those segments on there. So the very first thing they talk about is on the IP version 4 address, and I wished I had my little tablet, but it wouldn't work with me right now anyway because I couldn't hook it up to anything because I can't hook it up to the phone, and that's where I'm having to work from right now. So with your IP version 4 addresses, they're 4 octets long. Okay? Each of the octets are 1 byte long. And because they're each 1 byte long, that means the values in each of them can vary from 0 to 255. So you're taking a binary number there, the biggest binary number you can fit in 1 byte, which is 8 binary digits. And if you remember back to when I taught you binary numbers a few chapters ago, the 8 of them would be the 1s, the 2s, the 4s, the 8s, the 16s, the 32s, the 64s, and the 128s. Well, if we put a 1 in all 8 columns, then and add up those column values, we will come to 255. So that's where the max comes from on each of those. That's the biggest binary number we can get in each byte. So it's going to be expressed in decimal numbers normally. And so you're going to see it as 4 separated numbers separated by periods. So there'll be 3 periods between them. So that's going to be your IP version 4 address. Now, with that address, it's got 2 parts. The first part of it to the left is going to be the network portion. And then on the right side, there will be what they call the host portion. The network portion tells us what network does it belong to. And then the host portion is what's the specific machine on that network. Now, how many of the bytes or bits are contained by the network portion and how many are contained by the host portion will depend on the addresses. And this is where one of the problems with IP version 4 runs into. And remember, IP version 4 was developed back about 1980. The internet existed. The World Wide Web did not exist. Any idea of people having desktop computers, all of that was science fiction off into the future. You just had big machines and you had terminals attached to them and such mainly. And so you weren't going to have very many connections to it. So they came up with this system to it that they call a class system. And that they said, okay, when we develop this system, we're going to do a system that we're going to do it, make it easy looking at those addresses. So, and I will go through on Wednesday and show you exactly how this digs out of here. But basically, addresses 1 through 127. Now, 127 is a iffy one. Are all Class A addresses, 1 to 127. Now, 127 actually is a loopback address. Actually, it's a ton of loopback addresses, about 1.4 million of them, and we only need 1. And that's part of where they inefficiently designed it. Class A addresses, you got lots of hosts per network. Here's the second part. A Class A address, it uses the first octet for the network, and the last 3 octets tell you what the host number are. So as part of that, then you got to have a way to know when you look at them, what's the portion that's the network portion and what's the portion that's the host portion. That is what a subnet mask does. A subnet mask merely says this portion of the address is the network portion, the rest of it's the host portion. And so with that, what you're going to end up with is we're going to put binary ones in the subnet mask on the portion of the address area that would be the network portion. We're going to put binary zeros in the portion that will be the host portion. So that means a subnet mask always starts with binary ones and it always ends with binary zeros, and the two don't mix up. You do the binary ones to the end of them, and then you do binary zeros from there on out. Um, so, and because of that, because we said it was binary ones for the network portion, and that's the first part on the left. When y'all have seen subnet hosts before, you've seen things that looked like 255.255.255.0. Well, they can be all kinds of numbers in there, as we will see on Wednesday with subnetting. But for right now, on just a class approach, which is all I want you to see right at the moment today, is that class A has a subnet mask of 255.0.0.0, which means the network portion of the address is in the first octet, and the other three octets are just the host portion. There are class B addresses. They have less host, but there are more networks available. And those range from 128 to 191. Okay. Class C addresses range from 192 to 223. And I'll show you how they came up with those numbers, like I say, on Wednesday. But for the moment, just picture on that. There is a class E, but that's for multicast, where you're sending something out to multiple state addresses at one time. And so it's got its little range. That's actually class D, I meant, not E. And then there is a class E, which is the leftover ones, which you'll see quite often expressed as experimental. Some books won't even mention class E. It really does exist. The federal government, when they created the internet back there and created addressing system, the internet came from the United States and then went to the rest of the world. They reserve stuff for them. So there are addresses that are above, up in the up to 255 that you're not going to normally see. They're used by the military and the government. I've never seen one of those addresses, which is actually a range of 240 to 255. The one below that, the class D, was 239, was 224 to 239. And if I had seen one of those addresses up there in that class E area, I probably couldn't tell you about it. That I'd have to kill you if I told you I had seen one. So they're there for special military government research purposes. So those are those. So they also talk about prefixes and mention that besides the subnet mask. Subnet mask can be in long form, which is what I just told you about, or it can be in a short form where we put a slash and the number of binary digits that makes up the network portion after the network address. Now, in the Cisco equipment, it's going to require on IP version 4 you use the long form. On IP version 6, it's going to let you use, it's going to have you use the short form. And you'll see it written both ways sometimes out there. So be aware of both short form and long form. Long form says that it's all those things like 255.255.0.0, and so on, and all kinds of other numbers too. And I remember when I first started learning this, that's what I thought they were. Actually, I got an MCSE, which is Microsoft's premier networking certification they had, without understanding it got into subnetting and all of that stuff. When I got to Cisco, I learned how to do all of that. That's what I'm going to teach you Wednesday. And then the slash, so if it was a 255, 255, 255.0 in long form, in shorthand, what that would be /24, because we filled in 8 bits in each of 3 bytes for the network portion. So it would be a /24. They get into anding and oring. Don't bog down on that. Wait till you listen to my lecture on Wednesday about how we're going to do subnetting. I'm going to teach you all about dealing with that. And I don't like anding and oring. I'm going to essentially teach it to you, but we're not going to do it as anding and oring. So don't bog yourself into that stuff at all. I'm going to come back and teach you on that. They talk about networks, network addresses, host addresses, and broadcast addresses. Because when we look at that address, it actually has, there's 3 types of them that we'll see for each network. So a network address has the network number in the network portion, but in the host portion, it's all binary zeros. So simplistically putting it, you'll see it sometimes as .0, but it can be something different than that as long as it's ending wherever the subnet mask ends at, where the host begins, that the host portion is all binary 0. So the network address is all binary 0 for the host portion. It's not assigned to a specific machine. So that tells you here's the network address. The broadcast address will go on the opposite end of the line when we start drawing some charts on Wednesday. And what that is that's an address that says if it sees this address, send it to every device on the network. And what it's got in there is it will have all binary 1s in the broadcast portion. You'll see it as 255 if it was a purely classful address, is where it ends with. But when it's not classful, it's going to be some different numbers, but it'll still be the host portion's all binary 1. And all that's saying is if the device sees this address traveling around, it means it goes to every device. It's a broadcast address. Host addresses will fall between those two, between the network that's all zeros for the host and the broadcast that's all binary 1s for the broadcast address. And my laptop is just now coming up. It just popped up with the screen on it. But I'm not going to touch on it because we're already halfway through time. So all of our hosts will have numbers in that range, which will be start from 1 binary after the network address, and it'll go to 1 less than the network, than the broadcast address. So, but keep those, but we'll come back and visit those again on Wednesday, and I think they'll make more sense when you see me draw some charts, and as we draw this charting in, and I'll explain those terms again. I know it's not the best of conditions today. They then talk about unicast, broadcast, and multicast. Well, I just told you about broadcast. Broadcast says this message goes to all machines on our broadcast domain. Okay, so it's everybody else that shares the same network. And so, and it will have, when it's sent out, like I say, binary 1, all binary 1s in the host portion. A unicast address is where we're sending a message out, and the address we're sending it to just has a network address and a specific host number that's going to 1 machine. Any questions on that? Um, and we're having to do this from phone today, Whitfield, because my computer decided to act up and it just came up. And so I'm using my phone to do it instead because that's the only way I had to connect in. Wednesday, we will have the other part of the session, and it better be on my laptop. So they go through and talk about each one of those. Broadcast goes to everything, and it has all binary ones in the host portion. Unicast goes to a specific machine, and it's got just a specific machine or specific host address sitting there in that IP address. Multicast is the third one. And multicast says this is something we're sending out to multiple addresses, but we're not sending separate messages to each one. We're sending one stream out and it goes to multiple ones of them, which cuts your amount of traffic. Where multicast gets usually used is for streaming purposes, which is why my word stream popped up in there. So when you're watching something that's streaming, it's going to usually be using multicast to do it. So they're not sending out 3 million copies of the same thing all over the world, which would bog down all our networks. Actually has locked up networks in the past. We're sending it out to go to multiple addresses at one time. And multicast is what allows you to do that. Does everybody see what I'm talking about on multicast, broadcast, and unicast? Unicast goes to a single machine. Multicast goes to a group of machines. And broadcast goes to every machine. Broadcast has all binary ones in the host portion. And then the network address to mix in with all of that is it has for the host just binary zeros because it's really not to a specific one. They then talk about public and private IP addresses. Because the other part they set up and they created it all was they realized not everybody was going to be connected to the internet. Now, one of the restrictions because of how they set it up was like on Class A addresses said there's only 126 of them plus 127 that's the loopback. Big companies got given Class A addresses. They had millions of host addresses available to them. How many companies do you know even today need millions of host addresses? Note the IBM, AT&T, and some other companies like that back in 1980 got given a Class A address. When things fell apart in the late 90s, when the World Wide Web appeared and we ran out of addresses and they went to take back addresses, most companies gave them back and just took a small subset of it that they just of the amount they needed. However, I think it was AT&T went to court and got to keep their address because they proved in the documents from back there in the 80s that they weren't just leased these addresses, that I gave them the address and they said, we want to keep that address. I'm not sure if they're still using them or not, but there are private and public addresses. Public addresses are addresses that work on the internet. So anytime we get given an address that is an actual real address on the internet, it is a public address. Private addresses will not work on the actual internet. Now, prior to 1996 or so, everybody that went to connect to the internet, and when I connected Swainsboro Tech to the internet, I did the same thing, that they gave me a block of addresses. They actually gave me a Class C block, which had 254 host addresses in it for the whole school. And my question was, what will I ever use 254 addresses for? This is before phones, actually, smartphones. You were having early cellular phones appearing at that point, although most of you would all define them as granny phones today, because they were flip phones and such. But you had people getting their own laptops and stuff, but there was not everybody had one at home, a computer at home, etc. Now we got IP addresses everywhere. So they gave me that. I went around the school and I put a public address on every device in the school and used like 100 of those addresses. That's what everybody else in the world did too. There were very, very few firewalls out at that point. So you could sit on your computer and you could actually monitor traffic across the internet because everything came across your computer. And you could sit there and watch it all and monitor it all. And it was basically not encrypted either. Because that was before we started selling everything and everything. So you're just pretty much research stuff being shared before that point, although the buying and everything else was starting to appear. So the world was changing. So everybody got public IP addresses that were going to be on the internet connected. However, well, the problem is we ran out of addresses. So they also had private addresses out there. The intention of the private address was that if you were going to set up a computer network, which plenty of organizations did in the 80s, that they weren't connecting to the internet. They were just wanting a network within their company so they could share resources within their organization. I set that up in a number of companies. But you weren't connecting out onto the internet, so they said, here's the addresses to use for these. And they gave 3 different sets of private IP addresses, a class A one, a class B, actually 15 class B ones, and then a group of class C ones. So they set those up and said, use these if you're not connecting to the internet, and that the internet will not recognize those addresses. Those address numbers will look familiar to some of y'all because anytime there's examples given or you've heard me give examples, I use those private numbers because they don't really exist out there. They exist within private networks, but not out, but they won't work on the internet. They are like on telephone numbers. And I don't know if y'all knew this or not, but the exchange 555 does not exist as far as the telephone company is concerned. They don't. They've got all of their equipment set up to ignore any phone call that goes to 555, whatever. That one is meant to be used for private purposes. Main purpose they've got that one intended to use for is for when you put it in a song, that if I'm going to write a song about the wonderful things of IP addresses and telephone numbers is that I love the number 555-1832. I love the number 555-1852. You can call 555-1852 all day long and you won't get anything because it's a private, non-existent number. Private IP addresses work the same. Now, there's a song from back in the 60s, and one of you, I think, reminded me the other day what it was, that they used a real number, and it drives people crazy still to today because of it. They should have done a 555 number. I just did in the song I just wrote and sang for y'all. And so you've got 3 ranges. Class A, it's any number that starts with 10. So the first position's 10, and anything else on it, it's a private IP address. Wasteful again. B, this one's the one that'll be harder for you to remember, but I would tell you this. Remember, the first number is the critical part. It starts with 172, and then it goes on to that it's 172.16 dot anything through 172.31 dot anything. But I'll tell you this, all the tests and certs I've taken, I don't remember ever seeing anything where I needed to know beyond 172 of the right answer. Class C is 192.168. And so you'll see those referenced. And when you hear me give y'all an example of an IP address, you see I use those numbers. I'm using fake numbers. So those are private IP addresses. They list them for you in the book too, so that you can see them. And then if I say private ones will not route across the internet. Now, what happened there in the late 1990s when we ran out of IP addresses, we suddenly realized, wait a minute, we can use NAT, Network Address Translation. And with NAT, we can use private IP addresses inside the network. And then connecting to the outside world, we can use one public address for our whole big network, and they'll all share that same public IP address, and we had just saved a ton of addresses. And then the NAT server will do the conversion back and forth as traffic goes back and forth on it. And it does a wonderful job, and it's extended IP version 4 from when we ran out back in like 98 or so of addresses to where we just now ran out again about 2 years ago, although we're still stretching it right now, and we'll make it on because we're moving into IP version 6. So loopback addresses is where you use an address that if you send something to that address, you're saying you're testing your connection to the network on your computer is all you're doing with a loopback address. It's just going to the connection and bouncing back and telling you, is it good or not? IP version 4, it uses an address that starts with 127. IP version 6, this is the only address I can tell you in it is ::1, i.e. it is 31 binary zeros followed by a binary 1. That's the only one I can tell you about. So then they tell you a little more on that, and then they're going to get into how we're going to segment them and how we're going to do subnetting, and that's going to finish out the chapter. And wait till for me to go over it at this point, please. I'm going to do it differently than they do to a good degree. We'll end up with the same answers, but I think my way is a lot easier. And then VLSM is where you subnet the subnet. Any questions? Because we've now, we've only used up 45 minutes, but I knew this is going to take about 2.5 hours or more. So I figured today was going to be a tiny bit shorter, but I can assure you Wednesday's going to be, it's going to take us well over an hour. And if y'all can't sit in for the whole thing, that's fine. And I'll be recording it too. I'm going to be doing lots of drawing on my tablet, and we're going to see lots of ones and zeros as we work through it all. I'm going to show you how to draw charts and how to figure things out without having to do everything and get your answers to questions, because you will get questions on test and certification exams about what's the third host address on the fourth subnet of breaking up this network into certain size subnets. So I'm going to teach all of that to you on Wednesday. Any questions for me? And I'm going to check to make sure, see if anyone else came in. I know I picked up Whitfield already. I'm going to see if there's anyone else joined in. 6, 7. Yes, somebody else has joined in. I see who it is. And definitely William. Okay, I got Alexa. Okay, I got all of that. Schedule for doing the cabling, I have not got that developed yet. I'm going to try to work on that hopefully later today. I've got the great discussions too. Last week just knocked me completely backward. The end of the week, I did get to start doing a good bit, so I've done some grading. Actually, in your class, I've got at least, I'm pretty close to being caught up through last Monday, except for things that were resubmitted. Um, and I'm going to continue to work on that, but I'm going to work on getting a schedule for us in the next day or two. But I do not have the schedule for cabling out yet. But the other part is, I've already described this week to you. I've got collaborate sessions today, tomorrow, and Wednesday. And then Thursday that I speak at that conference, and I got a meeting in Calhoun part of the day too. So that day is pretty well filled out anyway. So it'd have to be next week, basically. And by Friday afternoon, I'll be on the road to Tennessee. So it'd have to be pretty much next week. But I'm going to get that done as quickly as possible. So the fact you don't see the schedule yet, that's correct. I don't have it done yet. And the other things have gotten in the way, and I'm trying to get priorities. And my health got the biggest thing in the way. So, all right, questions with me, or questions for me about what all we've done. Have you got any questions today? I hope y'all were able to follow on this, and the phone worked out okay for us. Now that the laptop's back up and stuff, I think we'll be fine. If you will look in the grade book Whitfield, there is a column there for permission slip. And if I've got your permission slip, there's 100 in there. There's no grade there if I don't have your permission slip yet. However, it does not count in your grade. It's just I'm using grade book, just like I've got another column in the grade book. Well, actually, that one's going to count. But the permission slip one does not count in your grade. It's just the grade book makes a real handy management tool for me to use, that I stuck a column in there that I specifically said does not count in grade, where every time I get somebody's permission slip, I put 100 in there so I can spot it real easily, and y'all can spot real easily. Okay. And then any other questions for me today? Email me questions. I answered emails all of last week. The only times I did not answer emails was Saturday, Sunday, and Monday until Monday afternoon, evening. I think it was late evening when I finally got on, felt good enough to get up and get on the computer, set the computer up, get on it, and then answered emails. But I worked a couple of hours on Monday night answering all the emails. I have answered most emails today that came in yesterday and this morning, unless they've come in since I left school at 9:30. So I'm pretty well caught up on that too. I answered emails all week and right on through yesterday. And I was grading papers yesterday for several hours. Your class was one of the ones I worked on. When you hit problems on that, my suggestion to you is you send me an email immediately at that point and tell me. Shouldn't be a problem because the tests y'all are taking are coming from Cisco, and normally there's not ever a problem on their end. Usually when people have a problem with trying to access the test or whatever, it turns out it is on the user's end. But anytime y'all have problems with tests, y'all should be writing me immediately after you've taken, when you finished that test or stopped, to let me know. Because that's when I need to look at stuff and see if I can see anything wrong or whatever. Obviously, I can't go back and look at anything at this point now. So, all right. Any other questions? But that's always an issue with doing these tests online and doing the classes online is internet connectivity can be problems at times. Um, and this cold spell probably has not helped anything right at the moment because it's knocking the electricity people crazy. And number two, lots of people are staying in that would have been outside and are using the internet instead. And so we've got some extra traffic on that. All right, if there's no other questions, I'm going to go ahead and let y'all go. Anybody got anything else? But again, if you hit a problem, let me know ASAP. And again, I'm on there most of the time. So I am going to see if I can pull this off still. So I will see y'all on Wednesday for the next session. You can come to 2 o'clock or 10 o'clock Wednesday. And watch that with me on that. And like I say, I intend it to be lots of drawing by me, highly active. If I was giving the lecture in the classroom, I would cover up marker board after marker board after marker board while teaching it. And so I'm going to use that little pad that I've got that the writing seems to really go nicely and that it's not been too difficult for me to use. So now if I can figure out how to stop the recording. So everything works different on the phone. Wait a minute. I just saw that question pop up. Now let me try to pull it back up because I just caught a couple of things on it as it disappeared off my screen. So.
Oh, I was just asking, does Cisco actually update us regularly on when they do like contests?
See.
Uh-oh.
I see something about Cisco update that I have. I did the judging the other week, took my first part, and that went well. So that now I'm a novice judge, and I got to do 4 judgings, but I got to find times when I can do them. They don't have them very often, but y'all should get notices about them. I try to post them out when I see them, but I may not have much recently, but it's not very often. But when I see something, I'll try to remember to go ahead and post it out to y'all. And I may learn something in the next day or two because they just did updates. I believe it was last week, and I need to watch those. I'm usually watch them live, but that wasn't the case last week, so I'll watch them on the recordings. Um, so now I'm going to try to go back again and stop the recording. So I think I answered what Mason was asking me. Right, Mason? You can nod your head. Okay. Because I've just took the chat off the screen. I'm just seeing your face right now, and that made it easier. And he did nod yes to me in case y'all are